Hello, scholars, and welcome to our lesson on finding a leg using the converse of the Pythagorean theorem. This is in angles and triangle theorems, and the goal is that you will be able to find a leg of a triangle using the converse of the Pythagorean theorem. The reason we're working so much with angles and triangles is because, as mentioned previously, triangles are one of our most important and used shapes both in our physical world and mathematically, as well as digitally. Being able to know how to better work with triangles and find missing pieces of them helps us better work in the world we live in. Let's begin. First, with our warm-up pop-up. If we know the amount of squares needed for the hypotenuse and one of the legs, can you figure out how many squares make up our other leg? Now's your challenge to figure out. How many squares are in our missing leg? All right, doing a check-in. There are, as always in math, a lot of ways you could think about doing this. If you think about one of our previous lessons, though, where you learned that the whole idea of the Pythagorean theorem is that two squared legs together make up the hypotenuse. So hypothetically, if you thought, well, if I take away what I do have from the whole, I should be left with my other part, right? If you thought the same thing, this is a 3x3 square. So if we just cut out a 3x3 square, then said, well, what do we have left? Hypothetically, that should be the area of the missing leg, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. However you figured it out, if you did figure out that the area of the other leg was 16, you did correctly find the missing piece, which is the whole idea what we're talking about today, kind of undoing the Pythagorean theorem. I'm going to clear this up, and let's actually look at the converse of the Pythagorean theorem. Once again, this is only working if a triangle is a right triangle. Just always remember that. If we can take the hypotenuse squared and subtract one of the legs squared, you will get the other leg squared. In other words, the warm-up problem. Or if you want to simplify it, c squared minus a squared equals b squared. Converse kind of means to undo something, and that's what this does. Instead of adding the two legs together to the hypotenuse, if you're missing a leg, you can do the same process, but now subtract your numbers. Find the root, and you'll find the missing leg. Well, let's actually do that in some problems. This is find the missing leg of each triangle below. Step 1, identify your given leg and hypotenuse legs. So remember, this time we're not given two legs, we're given one leg and the hypotenuse. That's our first step. Look at the two numbers we have. Step 2, put them into the converse Pythagorean, which is, again, the hypotenuse or the bigger number squared minus the smaller number squared equals our missing piece, our other leg squared. So let's write that in. We have 5 squared. And again, we're doing subtraction now, so minus 3 squared should equal x squared, our missing leg. Just like in the normal Pythagorean theorem, most of the process stays exactly the same. The only difference is we're going to subtract the two numbers, not add them. But that is literally the only difference. So for 5 squared, or 5 times 5, we would get 25. And then for 3 squared, or 3 times 3, we would get 9. Meaning our next task is to not add, but subtract them. Again, that is the only difference. If we are looking for a leg, we subtract. We add if we're looking for the hypotenuse. On that note, 25 minus 9 gives me 16. So that equals 16. Though remember, that is the value of x squared. To find out what the actual side length is, we need to find the root, or ask ourselves, what number times itself gives you 16? Which I could use a calculator, but I'm pretty confident that 4 times 4 gives me 16. Meaning x, our missing side length, our missing leg, is 4. So I'll just box it over here. Again, almost identical to the normal Pythagorean theorem, but we subtract instead of adding, and that is the only difference. Let's do it again in the other example. This one, we have 37 as the hypotenuse, so I could put down here 37 to the power of 2, or 37 squared. And we are going to be subtracting the given leg squared, or to the power of 2. And that should give us the square of our missing leg. Just like before. This time I'm definitely going to use a calculator though, because I definitely cannot do 37 times 37 quickly in my head. In the calculator, 37 times 37 is 1,369. We're also going to use a calculator for 35 because I also cannot quickly do 35 times itself in my head. So 35 times 35 is 1,225. So if we put that in, I'm going to now subtract them. So 1,369 minus 1,225, I get 144. And remember, the whole idea is this is supposed to equal x to the power of 2. Meaning, to find out, well, then what is x? I gotta find the root. Or I'm asking myself, what number times itself gives me 144? Again, I could try to figure it out, or I could use the root on my calculator. So I'm going to go to my root symbol on my calculator. I'm going to put 144. I get 12, which, yeah, that makes sense. 12 times 12 is 144. That means that x is 12. And those are my two legs found. Again, very, very similar to the normal Pythagorean theorem when you're looking for the hypotenuse, the longest side. The only thing that changes is we do the opposite of adding, which is subtracting. That's it. Everything else stays the same. With that, pause if you need to get your notes in, but I'm going to clear this up. So I guess I will go over it. We kind of went through, but we already squared our hypotenuse and subtracted them, then found the root. Again, just like with the Pythagorean theorem, but now we subtract instead of adding. I'm going to clear this up. Let's go to the U-try. So it's time for you to try to find the legs of these two triangles using the converse of the Pythagorean theorem. So pause and get your answers. All right, doing a check-in. If you don't have your answers, pause still to get them in, but if you're ready, let's review. So your biggest side, your hypotenuse, is 17. So if you knew to put 17 to the power of 2, you would have been right. You then had a leg of 8. So if you put minus 8 to the power of 2, and you said that all of this equals x squared, that means you successfully set up your equation. From here, if you knew to do 17 times 17, which, again, I'm using a calculator, not the easiest quick math to do, 17 times 17 is 289. So if you got 289, you were good. You then had to, of course, do 8 times 8, which that one I can confidently say is 64. So if you got 289 minus 64, then you were doing wonderfully so far. Your next step is your subtraction. So if you did 289 minus 64, and you got 225, then you would have been absolutely correct. Lastly, if you knew to find the root of both of these sides, in other words, what number times itself gives you this number, you could have done this in your head, or you could have used a calculator. Let's see. What number times itself gives you 225? Well, I know 10 times 10 is 100. If I keep going up, or I could use a calculator, I believe 15. 15 times 15 gives you 225. So if you also got that x is 15, or 15 is x, then you correctly solved A. Same idea for the next problem. This time you had 13. So if you did 13 to the power of 2, you would have been right. And then you had a leg of 5. So if you put, again, minus 5 to the power of 2, and said that all of this equals x to the power of 2, Then you successfully set up your equation. From here, doing all of the additional work, you have your 13 times 13, which I think we just did that a moment ago. You get 169. And then you do 5 times 5, which is 25. Don't need a calculator for that one. And all this is still equal to x to the power of 2. Next, if you subtracted 169 minus 25, you should have gotten 144. Equals x to the power of 2, which you could use your calculator, or we actually had this as one of our answers before. Coincidentally, I know that 12 times 12 gives me 144. So then x is 12. If you got 15 for triangle A and 12 for triangle B, then you absolutely use the converse of the Pythagorean theorem correctly. This is the time where if you did make any mistakes, please correct them now. But I'm going to clear this up and head to the closing. The closing is that we can use the converse of the Pythagorean theorem to find a leg of right triangles. So the normal Pythagorean theorem gives you the hypotenuse where you do addition with your two numbers. The converse, or the opposite, to find the opposite, find a leg when you are given the hypotenuse and a leg, is almost identical except for you subtract the numbers together, you do not add them. Otherwise, the process is exactly the same. With that, I'll be seeing you in some future problems, probably on Pythagorean theorem some more. But until then, goodbye for now.